Hello everybody, welcome to Mustcourse UBC Math 100 and 104 webinar. So before the tomorrow's final, we will go through both courses past exam questions. First, a few reminders. Please watch the webinar on a laptop or a desktop. So the mobile is not the best way to watch the webinar, and you can change the quality to HD to see my writing better. Okay, and you have already seen the chat panel, so you can ask your questions via the chat panel anytime. I will try to immediately answer your questions, and please ask your questions anytime, and please direct me through the webinar. So we have very nice past exam questions for both courses, and both courses have a very large intersection. So the topics are mostly derivatives, functions, and functional optimization. First, we will solve a derivation question, the derivative of fx x to the power x minus 1. So here we need to find the derivative. But how? The thing is, we have both x's on the base and on the power. So what are we gonna do? The best way to take the power to the base is taking logs. So I take the log of both sides. ln fx equals to x minus 1 ln x. So to make things easier, what I do is I write y instead of fx. So you don't need to, but I think that it's a better way to just understand what we do. And x minus 1 times ln x. Okay, so now I differentiate both sides with respect to x, okay? Because what I need to reach is the derivative of fx. So f prime x dy over dx. So it's my goal. I want to reach dy over dx. So what I do is differentiating both sides with respect to x. So d ln y with respect to dx equals to dx minus 1 ln x, okay, over dx. So this is called implicit differentiation, because now on the left hand side we have ln y, and I will differentiate ln y with respect to x. First, ln y with respect to y, which is 1 over y, right? So derivative of ln something is 1 over that something, right? Times, now do I know dy over dx? No. So just write that as an unknown. And I write dy over dx here. Equals to. On the right hand side, it's all x's. And they are multiplied. So just do product rule. Derivative of x minus 1, which is 1, times ln x, plus x minus 1 times derivative of ln x, which is 1 over x. Okay? So what I did is derivative of x minus 1 times ln x plus ln x, derivative of ln x times x minus 1. And the last thing is dy over dx. So send y here, okay? Y times ln x plus x minus 1 over x. But I need to replace y with x terms. What is y? It was x to the power x minus 1. So x to the power x minus 1 ln x plus x minus 1 over x. Okay, that is the derivative. And I check the choices. So I have x to the power x minus 1 here, and I have, what I have is ln x. Here I have ln x, and x minus 1 over x here. Okay, that is the answer. So please, as I said before, please direct me. Like, if this is a very easy question, tell me. Or if you want more of this type of questions, please tell me. Okay, so this is, this webinar. At the end of this webinar, I want all of you to feel much more comfortable for tomorrow's final. Okay, so I read your comments. So, there are some requests for remainder theorem. It's not so difficult. And one about limits, I will take that into account. And derivative of inverse functions, okay, maybe. Okay, so please now write me. So here we are like 15 people. Please write me if you are taking 100 or 104. So please write me you are an engineering student or you are a business or econ student. Okay, please write me that. And because I prepared questions from both courses, past exam questions, so maybe I can, uh, if everyone is from, let's say, 104, I can do more questions from that course, for example. So please write through the chat panel. So the second one, a ball is thrown upward from a roof of a 50-foot building with initial velocity of 96 feet per second. The height after t seconds, is given by ht 50 plus 96t minus 16t square. So determine the maximum height that the ball reaches. So the thing is, we already have the height function. It is 50 plus 96t minus 16t square. Okay? So how can we find 16t square? How can we find the maximum height? Okay, so now just while you are answering my question, I'm checking your comments. So there are students from both courses. Okay, so don't worry, both courses have a huge intersection, and I prepared questions from both past exam questions. Okay, and yes, any other? Okay, yes, I am Turkish. Merhaba. And okay, so how can we determine the maximum height? We have the function very explicitly, then we need to find the maximum value of the function, right? We need to find the maximum value of the function. So therefore, we need to take the derivative. So the derivative is 96 minus 32t. Derivative is 96 minus 32t. So which must be 0 in when the height is maximum. So therefore, I find t equals to 3. I find t equals to 3. So then I replace that in the function, and 50 plus 96 times t minus 16 times t square. Okay? So that's it. And which gives me, so I just calculate the value, 50 plus 96 times 3 minus 16 times 9. It is 194. So my question to you is, how am I going to be sure that this is the maximum value? So this is the value where the derivative equals to 0. But how am I going to be sure that this is the maximum value? This is the value that gives me the maximum height. Could you please write me? How am I going to be sure that this is the maximum value? Okay, I just check the second derivative. I just check the second derivative. The second derivative is minus 32, which is less than 0. And therefore, I know that this function has a concave shape like this, and the value where the derivative is 0 is the maximum value. Okay? Okay, I can't see any comments. Please write me some comments so that I can be sure that there's not a technical problem, but you just don't write. Could you please write me something? So did you understand the solution? So since the second derivative is less than 0, this is a maximum. Okay? Okay, great. I'm receiving the... Okay, good. I'm receiving the comments. Okay, very good. Very good. Please write me. So that was the second question. And the third one. So we are warming up. We have harder questions. Is that all we need to write for full marks? To prove it's a maximum. So since the second derivative is 0 throughout the whole function, then the point with first derivative being 0 must be a global maximum. Yes, that's the case. So like this has a shape of a parabola, like this parabola with a maximum. So therefore this must be a global maximum, right? Why is that a parabola? Because it has a degree of 2. So therefore, this information is sufficient to conclude that that's the maximum. Okay? Is that clear? So we have a continuous function. We have a continuous function defined for all real numbers. Suppose fx is increasing on the intervals from negative infinity to minus 1, and from 3 to positive infinity. And we are given that f minus 1 equals to 2 and f3 equals to 1. How many zeros does fx have? So let's just locate the given information. We have f minus 1 equals to 2. Here we have a point like that. And we have f3 equals to 1. So f3 equals to 1. So what we need to know is how many zeros does fx have? And we also know that here, from negative infinity till minus 1, here function is increasing. Here function is increasing. And here function is, on this region, function is decreasing. Okay, so now I'm sure that since the function is decreasing here and it is continuous, it must go from 2 to 1 here. Okay, it must be something like that. So now I need to think about these regions, the increasing regions. Okay, what do you think? How many zeros should this function have? What do you think about that? Okay, please write me. How many zeros does fx have? What do you know? 0. Okay, one answer. But any other answers? Any other answers? So, okay, here increasing, right? So it is f3 is 1, and then it must be something like that. f3 is 1, and it must be something like that. Okay? Yes. Why is that? Why is that? Because there are two possible cases. So we have determined this region and this region. But here, there are two possible cases. The first one is this one. The second one is this one. Okay? So we cannot determine from the information given. Okay? So since there are two possible cases before x equals to minus 1, then we cannot determine. And find the derivative of y equals to e to the power sin x squared. So this is a classic chain rule question. So I will be very quick about this one. So dy over dx. First, think that if you are having a difficulty with chain rule, think it like that. What is the derivative of e to the power something? So what is the derivative of? Don't confuse with the symbols. Just think about what's the derivative of e to the power something. The answer is e to the power something. So e to the power sin x squared. Then chain rule implies that. Then go through with the power. So then the next one is sin x squared. The next one is sin x squared. So ask yourself, what is the derivative of sin something? So the answer is cos that something. Cos x squared. Now, what's next? At last, we have x squared. So ask yourself, what's the derivative of x squared? And the answer is very simple, 2x. So multiplication of all these three gives you the derivative, right? So this was a very, informative chain rule question. So just follow these steps and you will be able to solve all chain rule questions. Okay? So, do you have any questions about that? And meanwhile, please write me if you have general comments about the webinar. For example, we will solve more difficult questions, but up to now, is that going okay? Okay. Or do you have something else in your minds? Okay, please help me through the webinar. But as I told you, um, we have very nice past exam questions, and if you can understand how we solve these questions, you will feel much more comfortable after the webinar. So now then, okay, I will try to be more interactive. Xy satisfy the equation x to the power y, 5 equals to 5y minus x plus 1, and find the derivative of y with respect to x at the point 1 over 5. I'm asking you, what should I do? Okay, I write the equation 5y minus x plus 1. Okay, what should I do? Tell me. I need to find the derivative. I need to find the derivative dy over dx. But how? Exactly, Mina. Why? Because, yes. Okay, very good. Because that x to the power of y making our lives difficult, right? So let's just take logs. Okay. Then y ln x equals to ln 5y minus x plus 1. And now, implicit differentiation. Take derivative of both sides with respect to x. Okay? With respect to x. So, first, left-hand side. Y times ln x. What are we going to do? Product rule. The derivative of y with respect to x, dy over dx. I don't know that. And I just write. Okay, I'll write y prime because it's going to be easier. Y prime times ln x as it is plus y times derivative of ln x, which is 1 over x, equals to. Now, we have ln 5y minus x plus 1. Okay? This is 1 over 5y minus x plus 1, as we do in the chain rule questions. Okay? Because the derivative of ln something is 1 over something times the derivative of 5y minus x plus 1. What's the derivative of 5y? 5y prime minus, what's the derivative of x with respect to x? 1. And the derivative of 1 is just 0. Okay, so I have the derivative. So here, don't forget that you need dy over dx at the point 1 over 5. You don't need to find the functional form. So just x equals to 1, y equals to 1 over 5. Just replace these values and find the derivative. So the derivative y prime when x is 1, I just write that, times ln 1 plus 1 over 5 times 1 over 1 equals to 1 over 5 times 1 over 5, 1 minus 1 plus 1 times 5 y prime when x is 1 minus 1. Okay, so ln 1 is 0. 1 over 5 equals to, here, that's 1, 5y prime minus 1. So 6 over 5 is y prime, 5y prime, and y prime is 6 over 25. Let's see. Yes. Okay. Is that clear? Please write me if that's clear, because I just need the derivative at that point. At that point, I just need the derivative at that point. So therefore, I just replaced the values and I found the derivative. Okay? Please write me if there's something not clear. Okay, I'll solve a problem first, because I can imagine that many of you may have difficulty in this type of problems. Am I right? So, okay. Okay. Okay, Jaden, I'm planning to solve this one first, and then I'll go through your question. But do you have, just answer me, do you have difficulty in this type of problems? What do you say? So, because, this type of problems, it may be hard to construct the equation and finding the derivative. Okay, I want to solve this one. A bucket is 60 centimeter high, has a radius of 40 centimeter at the top, and 10 centimeter at the bottom. Water is being dumped into the bucket at a rate of 1 liter per minute. How fast is the water level rising when the water is 30 centimeter deep? Okay, you may use the fact that, okay, volume, we know the volume, and then we need to find, just let me write 1 over 3 pH R2 square plus R1 R2 plus R1 square. So we need to find dH over dt. Okay, we need to find dH over dt. Okay, but we must use this equation and we must know R1 and R2. So what do we do? Please tell me. What do we do? Or just tell me what's in your mind to approach this question. Right? What do you think about that? So what can we do here? Okay, I can't see any comments. Please comment. Derive it. Okay. But here, the problem is we will derive that. But the problem is, Mina, can you answer what is R1 and what is R2? What is R1 and what is R2? Can you tell that? Do we know? What does it mean? Are we still waiting on this? What does it mean? So, do we know R1 and R2? So, we don't know that. The problem with that question is, okay, we have water filling the bucket. We have here the bottom R1 constant. No. The problem with this question is R1 is constant because the bottom, the water must fill the bottom first. R1 must be 10 centimeter, but R2 is changing. Because, for example, when the water is the bucket is half filled, R2 is something different. When the bucket is quarter filled, R2 is different. R2 is 40 when the bucket is all full, right? So 40, R2 being 40 is just 1 point. When the bucket is full, R2 is 40. But in the rest, R2 is all changing. Do you understand that? This is the key to this question. This question is very hard just because of that. Okay? Do you understand that? Do you understand? R2 is changing. So this is the first. This is the first step to solve this question. Okay, the second step. The second step is deriving an equation for R2. Okay, so this is the bucket. Okay, this is 40, the top, and this is 10, the bottom, 10, the bottom, and this is 60 centimeter here. Here is 60 centimeter. And at any time when the water is filled with water, this is R2 and this is height. So the only way to derive an equation for R2 is just thinking about this triangle. Here, this is a triangle. And here, let's call it X. My first question, how to find X? How are we gonna find X? Because if we can find X, we can find an equation for R2. Okay? The first step is finding X. X over, so for triangles, we have something like X over X plus 60 equals to 10 over 40. This is how we are going to use that 40. It's just to calculate X. Okay? So 40x equals to 10x plus 600. 30x is 600 and x is 20. This is 20 centimeters. Yes, exactly. Now we can write the equation for R2. Okay? So we have found x. So we have height here, 20 over 20 plus height equals to 10 over R2. That is the equation. So that means 2R2 equals to 20 plus height. Okay? 2R2 equals to 20 plus height. So therefore R2 equals to 20 plus height over 2, which is 10 plus height over 2. So if you understand this, the rest is just deriving. So let's take the volume equation and let's replace R2 by 10 plus h over 2. So volume equals to 1 over 3 p h, and I replace R2 by 10 plus h over 2 square plus, and remember R1 is 10 and it doesn't change, it is constant. So we can treat R1 as a constant. R1 equals to 10. So 10 times, what's R2? 10 over h over 2 and plus 10 square, which is 100. Okay? Okay, so this is a hard question, so please tell me if everything is okay. If everything is okay, please tell me. So what I do is let's say, try to make the right hand side simpler. So p over h and I multiply by h. So which is like 100 h plus, so 10 h square plus h square over 4, which leads to h cube over 4 plus 100 h square, 100 h square plus, so 5h and 5, let's say here it's not 100h square, it's 100h, and 5h square plus 100. Okay? So, therefore, let's derive d volume over dt equals to p over 3, 100 dh over dt, 100 dh over dt, and plus 20h times dh over dt, you know, I take the derivative, plus 3h square over 4 times dh over dt, plus 100 dh over dt. Okay? That's it. So, what do I know? I know that dv over dt is 1 liter. And I also know that h is 30 centimeters now. H is 30 centimeters. So dv over dt is 1, dv over dt equals to 1, and h is 30. When I replace both 1 equals to, and it's like 1 liter, and don't forget that 1 liter is 1,000 centimeter cubes, 1,000 centimeter cubes. So 1,000 equals to p over 3 times, just replace 100 h prime plus 20 times 30 times h prime, and then plus 3 times 30 square over 4 h prime, and finally 100 h prime. So it makes p over 2 h prime 100 plus 600 plus, so it is like 900 over 4, 225 times 675 plus 100. Okay? So which makes here, let's calculate, 1,475 over 3 times p, and therefore it is 1,000. H prime is 1,000 over 1,475, and here multiply by 3 and divide by p. Okay, that's it. So this is the way how you solve the question. There may be some calculation errors, but the thing you will focus on is finding here x, and then using that x to find an equation between h and r2, because r2 is all changing, and then using that for replacing r2 with a term in terms of h, and then differentiating both sides with respect to t, using dv over dt and finding dh over dt. Is that clear? Is that all clear? Please answer me. Okay. So Okay, could you please answer if you have any questions about the previous one, about the bucket problem? Okay, I'm gonna proceed with the next question, but first I need to be sure that whether your comments reaches me. So just a moment for that, please. Okay. 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 2015 question 11b. Okay, I have the question. It must be about errors, right? So I will solve that in the second part of the webinar. I will solve that error questions, the error bounds and stuff in the second part of the webinar. So let's solve one more question. Maybe you have some difficulty about Taylor polynomials, and then let's talk about the second part. Okay, so compute the Taylor polynomial of degree 3 of fx equals to x ln x at a equals to 1. So what's the formula for Taylor polynomials? The thing is, fx can be written as fa plus the first derivative of f at a, okay, times x minus a plus second derivative of f at a times x minus a square over 2 plus 2, let's say 2 factorial, and third derivative of f at a times x minus a cube over 3 factorial, and it goes on like this. So we need to find the first 4 terms, because we are required to find the Taylor polynomial of degree 3. It means that the first 4 terms. Okay, so therefore we need first the first derivative of f, which is found by the product rule, and ln x plus x over x, which is ln x plus 1. The first derivative is ln x plus 1. Okay? And the second derivative is therefore 1 over x. The third derivative is therefore minus 1 over x squared, right? So the value of the function at a, so a is 1, the value of function at 1 is 1 times ln 1, which is 0. The value of the first derivative at 1 is ln 1 plus 1, which is 1. The value of the second derivative at 1 is 1 over 1, right? Which is 1. And the value of the third derivative at 1 is, what's that? Minus 1 over 1, which is minus 1. Okay? So, therefore, I just replace all these findings in the formula to find a third degree polynomial. First, fa, so f1, which is 0, plus f prime 1, which is 1, times x minus 1 plus second derivative of f at 1, which is 1, times x minus 1 square over 2, and the third derivative at 1, which is minus 1 times x minus 1 to the power 3 over 3 factorial, which makes x minus 1 plus x minus 1 square over 2 and minus x minus 1 cube over 6. So this is just an application of Taylor polynomials, Taylor formula to this function. Okay? So, one more question. And that is, suppose that a company's cost function is an increasing and differentiable function. Use calculus to show that average cost will be minimized at the level of production when the average cost is equal to the marginal cost. So first, let's think about the average cost. What is average cost? So we have a cost function in terms of, so what input changes the cost function. So we have, for example, higher costs if we, what do we do? If we produce more, right? So therefore, cost function is changing with respect to Q. Q is the amount of production. Q is the amount of production. And what do we know here? We know that cost function is an increasing and differentiable function. So since it's an increasing function, it means that the first derivative is greater than or equal to 0. Okay? And that's the next finding. So then we need to think about the average cost. What's the average cost? It is cost function divided by Q. So for example, if we produce 10 units of output and our cost is, let's say, 300, then the average cost is 30. What do I do to minimize the average cost? What do I do? So please answer me just at this point. I need your feedback. How can I minimize average cost? How can I minimize average cost? What do you say? Okay. I'm just waiting for your feedback. How can I minimize average cost? What do you say? So I need to minimize average cost, and how can I do that? Okay, I don't know whether if it is increasing the production or not. I don't know about that, right? So maybe it's increasing production or maybe it's decreasing. So how can I find the minimum point? The answer is very simple. What do we do for all functions? We just to find the candidate points, we just take the derivative. So take the derivative of average cost with respect to Q. So which means that take the derivative of total cost over Q with respect to Q. So as you can see, now we have a derivative. We have a derivative, but the thing to be differentiated is a division, right? It's a division. So I need to apply the division rule, the quotient rule. First, the derivative of total cost with respect to Q, and then times Q minus, I write the total cost as it is, times the derivative of Q with respect to Q, which is 1 over Q square, right? As it is in the quotient rule. Okay? So, what is the derivative of the cost function with respect to Q? It is the direct definition. It is the direct definition of marginal cost. Okay? So therefore, marginal cost times Q, okay? Marginal cost times Q minus marginal cost times Q minus total cost over Q square. So this is the derivative of average cost with respect to Q. So the derivative must be 0. Therefore, I have marginal cost times Q, right? Minus, let's divide them both. Marginal cost over Q minus total cost over Q square equals to 0. What I do, I just write marginal cost over Q minus total cost over Q times 1 over Q again equals to 0. And finally, marginal cost over Q minus, what is total cost over Q? It is average cost. So that makes average cost over Q equals to 0. And therefore, marginal cost over Q equals to average cost over Q, and marginal cost equals to average cost. So therefore, that is the point where the first derivative is being equal to 0. So what about being sure if that's a minimum point? So what do? I just differentiate the first derivative again. Okay? I just differentiate the first derivative again. So that is, it was what I have found. I have found the first derivative, marginal cost over Q minus, okay, average cost over Q. And if I differentiate again, I will show that the second derivative is smaller than zero, and when marginal cost equals to average cost. So here the thing is applying the quotient rule here and finding the derivative, finding the point where the derivative equals to 0, and then finding marginal cost equals to average cost. Okay, guys? So this was the end of the first part of our webinar. And during the first part, I have solved some questions from the past exams, okay? And during the second part, I will continue with questions from both courses past exams. But the second part will be through our website. You know, we just initiated this webinar through YouTube because, you know, maybe our website is not known at UBC, and then maybe YouTube could be more comfortable to begin with. So therefore, the second part will be through our website, and I will just post the link of the second part to YouTube chat. Just wait for a moment, and you know, here we have the link. Just a moment. Okay. So okay, just a moment, guys. And in the second part, you asked some, you wanted me to solve some error-bound questions. I'll do that. Okay. And I just, okay, posted the link. And the second part of the webinar will be for $10 US. You can pay by credit card through our website. And during the second part, you know, I would like to solve as many questions as possible from the past exams. And in the second part, you know, it's going to be more about your requests. And the part on YouTube will be loaded to the same link automatically in 5 or 10 minutes. So therefore, I will begin the second part at 11:20 p.m. Okay, 20 minutes later, I will begin the second part at 11:20 p.m. And you can send me your questions via my email address. Okay, you can send me your questions via my email address. So I hope to see you at the second part 20 minutes later, and you can just click the link I posted on the chat, and you can register for the second part for $10. And please send me your questions to this email address. And also, I have noted your requests for maximum errors. Okay, I know that, and I will solve questions about maximum errors. Hope to see you at the second part. Bye, guys.